Now let us understand what Mr. Stokes has to say about viscosity. Some opposition to the relative motion of the layers. It has greater viscosity. So you can see such applicative questions as temperature increases, viscosity decreases. Hello students. This is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. So we have a conclusive session on the chapter Mechanical Properties of Fluids. Before I continue, what did we study in our previous session? We studied about the dimensional formula for coefficient of viscosity. We understood that as temperature increases, the viscosity of liquids decrease. As temperature increases, viscosity of a gas increases. And finally, we studied Poiseuille's formula, which will help us to determine the coefficient of viscosity of a gas. Now, continuing in today's class, we will understand something called as Stokes Law, a very important 3-mark question in the exam. Stokes Law. Poiseuille's law says the volume of the liquid coming out per second through a tube is directly proportional to the 4th power of the radius, directly proportional to the pressure difference, and inversely proportional to the length of the tube. Now let us understand what Mr. Stokes has to say about viscosity. He says, when a sphere moves through a viscous medium, so I have a tube which is filled with a viscous oil. Probably I can also say glycerin, and a sphere is moving inside this viscous medium. It has to experience a retarding force, an opposing force due to the viscosity of the medium. The property of viscosity will oppose the motion of the sphere. So there is a retarding force. And this viscous force F acting on the small sphere of radius r, moving with a terminal velocity V, F is equal to 6 pi eta RV. And this is what is called as Stokes Law of Viscosity. The viscous force acting on a small sphere of radius r moving in a viscous medium of coefficient eta with a terminal velocity v, F equals 6 pi eta RV, and this law is established as Stokes Law of Viscosity. So very clearly we see the viscous force acting on the small sphere is directly proportional to the radius of the sphere, directly proportional to the terminal velocity of motion, and hence we call this as Stokes Law of Viscosity. Now, continuing further, since the entire chapter is conceptual, topic-based, most of the times asked as word markers or 2 markers, I have framed a set of questions which will help you to answer grammatically the question given. So let us try to understand a few concepts which we have already studied in the form of question and answers. First one, what is viscosity of fluids? Odidiva? Yes. What is that? The first thing you have to mention the word is, it is property of a fluid. It is the property of a fluid which opposes the relative motion between its adjacent layers. Helidnala. The different layers of the fluid will not allow other layers to move easily. There is some opposition to the relative motion of the layers, and that is what we call viscosity of fluids, which is also called fluid friction or internal friction. So viscosity is also called fluid friction or internal friction. Second one, a briskly stirred liquid. Briskly, you stir liquid in a beaker, comes out to rest after a short time. Why? This is due to the property of viscosity of liquid. So when you stir a liquid briskly in a beaker, you see the liquid comes out after a short time because it is held by the cohesive forces, something called viscosity of the liquid. A beaker containing water and another beaker containing glycerin are both stirred rapidly and kept on the table. One beaker contains water and the other beaker contains glycerin. Both of them are stirred rapidly and kept on the table. In which beaker liquid comes to rest earlier? It has to be the beaker containing glycerin. Why glycerin comes to rest at the earlier? Because it has greater viscosity. So you can see such applicative questions, narrowers for 1 mark may be asked. Define coefficient of viscosity. Umpty number of times we have done this. SI unit of viscosity by dimensional method, Newton second meter minus 2, but the most applied unit is what we call as decapoise. Again, for 1 mark, a short question, students. SI unit of viscosity. The SI unit of viscosity by dimensions, Newton second meter minus 2. But the conventionally followed unit is decapoise. Examly ಜಾಗೃತೆಯಿಂದ decapoise ಅಂತ ಬರಿಬೇಕಾಗುತ್ತೆ. What is the effect of temperature on viscosity of liquids? As temperature increases for a liquid, intermolecular distances proportionately increase. This increase in the intermolecular distance decreases the viscosity of a liquid. Therefore, for a liquid, as temperature increases, viscosity decreases. And for a gas, basically in a gas, diffusion of molecules from one layer to another is responsible for viscosity. As temperature increases, diffusion rate increases. Therefore, we see as temperature increases, viscosity of a gas increases. Terminal velocity, constant maximum velocity attained by the body as it falls through a viscous fluid under gravity. As a body comes down a viscous medium like glycerin, kerosene oil, any viscous medium, it will experience constant maximum velocity. And the constant maximum velocity attained under gravity is called terminal velocity. Expression for viscous force on a spherical body, Stokes law, which says F equals 6 pi eta RV. What is R? Radius of a small sphere V, terminal velocity, eta, coefficient of viscosity, and so on. What was Poisson's formula, which told V is equal to R to the power 4 P eta divided by L. Volume of the liquid coming out of a tube per second, directly proportional to 4th power of the radius, directly proportional to constant pressure between the ends, inversely proportional to the length of the tube. So, such questions, if you are familiar with, very easily in the exam, you can answer the 1 markers. In my next session, I'll come back with 1 mark clear-cut question and answers on surface tension and fluid mechanics. Until then, have a nice time. Thank you.